Good morning students, myself Dr. J.P. Sridhar, Associate Professor, Department of Electrical Engineering, SJVIT Bangalore. Today I am going to discuss on circular convolution method problems. Especially in that I am going to discuss on Stockhams method or DFT-IDFT method. Let us consider the problem. It goes like this. Find the circular convolution of the sequences by using Stockhams method or DFT and IDFT method. The given sequences are x1 of n is equal to 2, 1, 2, 1 and x2 of n is equal to 1, 2, 3, 4. Okay, so it is also called as frequency domain approach. It is also called another name of Stockhams method or DFT-IDFT method is frequency domain approach. Frequency domain approach. So you should be very careful in exam. So all the method, names are different, but the procedure, the method of calculating, the circular convolution remains same. So let us start our problem. So what is the sequence given? x1 of n is equal to 2, 1, 2, 1. So the length of x1 of n is equal to n1 is 4. And what is the length of x2 of n? That is n2, which is equal to 4. Observe, both the length of the sequences are matching, so there is no need to map any zeros. So to carry the convolution, the lengths are same of both the sequences, then you can go with the circular convolution directly. Now in this method, what we can do, there are two sequences, so we have to follow both DFT and IDFT method. So how to calculate? Now whatever x1 of 1 is given, for that you calculate the DFT, you will get x1 of k, and you will have x2 of n. What is the DFT here? 4-point DFT. Then we will have x2 of n. These are the 4-point DFT. You would calculate x2 of k. Once you know x1 of k and x2 of k, multiply these two. X1 of k and x2 of k, you will get y of k. What is y of k? Y of k is equal to x1 of k into x2 of k. You will get y of k. For y of k, you take the IDFT. Once you will get y of k, you take IDFT, you will get y of n. So this y of n contains also 4 samples because we are following the circular convolution. The length is 4, so your y of n should also have 4 samples. I hope everyone understood. Now x1 of n is given, calculate x1 of k. x2 of n is given, calculate x2 of k. Multiply x1 of k and x2 of k, you will get y of k. So for the y of k, you take IDFT, you will get y of n. Now what is x1 of n? x1 of n is 2, 1, 2, 1. So I will follow the matrix method. So I will calculate x1 of k. So how to do that? We will have 4 cross 4 matrix, x1 of 0, x1 of 1, x1 of 2, x1 of 3 is equal to, we will have the matrix. You can write, already told how to write this matrix. So 1 minus j minus 1 plus j, 1 minus 1, 1 minus 1 plus j minus 1 minus j. This is the total factor matrix of 4 cross 4, and we'll have the input 2, 1, 2, 1. You multiply each row with each column, you will get 6, 0, 2, 0. Similarly, what is my x1 of k? x1 of k is equal to 6, 0, 2, 0. In a similar manner, similarly calculate x2 of k. So what is x2 of k? x2 of 0, x2 of 1, x2 of 2, x2 of 3. So total factor matrix, you know that write 1 minus j minus 1 plus j, 1 minus 1, 1 minus 1, 1 plus j minus 1 minus j. The input sequences are 1, 2, 3, 4, and you will get answer is 10. So you will get 10 minus 2 plus 2j minus 2 minus 2 minus 2, this is the answer. So my x2 of k is equal to 10 minus 2 plus 2j minus 2 minus 2 minus 2j. This is my x2 of. Now once you calculate x1 of k and x2 of k, observe here. For x1 of n, I am calculating x1 of k. For x2 of n, I am calculating x2 of k. Now what is my y of k? Y of k is x1 of k into x2 of k. And now I will multiply both x1 of k and x2 of k. What is my x1 of k? x1 of k is equal to 6, 0, 2, 0. You multiply, you will get y of k. What is y of k? 10 into 6, 60. 0 multiply anything is 0. 2 into minus 2, minus 4. 0 multiply anything is 0. Therefore, my y of k is equal to, I will rewrite y of k. So y of k is equal to 60, 0, minus 4, 0. So once you get y of k, take IDFT of y of k, you will get y of n. How to calculate IDFT formula? What is the formula for IDFT? You know that x of n is equal to, what is the formula? 1 by n into summation k is equal to 0 to n minus 1 x of k omega n raised to the power of minus kn. This is the formula which we are using to calculate the IDFT. Now I am using the matrix method for the same. So I will write the matrix 4 cross 4 matrix by taking the complex conjugate of the total factors. So I will write the matrix for y of n. So y of 0, y of 1, y of 2, y of 3 is equal to, okay, in IDFT I will have 1 by 4, so 1 by n. So total factor matrix, it remains same. First row, first column, 1 minus j becomes plus j, minus 1 plus j becomes minus j, 1 minus 1, 1 minus 1 plus j becomes minus j, minus 1 minus j becomes plus j. And I have the y of n. So y of 0, that is 60, 0, minus 4, 0. So I will get 1 by 4 into 56. I'll write 1 by 4 into 56, 64, 56, 64. So therefore I'll get y of n is equal to 14, 16, 14, 16. So this is the answer obtained, okay, at the end by using a DFT method or Stockhams method, or is also called as frequency domain approach. You can also cross verify whether the answer is correct or not by using any of the method, matrix method or any of the method, to verify whether the answer is correct or not. You can do that. You will come to know if you are getting the correct answer or not. With this, I will conclude this class. Thank you.